Hello everyone, in this video I'll explain the chain rule for derivatives. So just a little bit of review what we already know about the derivative. So if you have to take the derivative of this polynomial y is equal to x squared plus 25, so we know that we take the derivative of each individual term and we get, so derivative would be, so derivative of x squared is 2x, derivative of 25 is 0, so 2x plus 0 is just 2x. Now let's take a look at the second example. So if you have y is equal to x squared plus 25 and the whole expression raised to power 3 over 2. So what can we do in this case? No doubt that we know that if we have to take the derivative of x raised to power 3 over 2, so we can use the power rule 3 over 2 and then decrease the power by 1, so half, x raised to power half. Because in this case it was a simpler problem. We had x here and we were taking derivative with respect to x. But now in this case, if I try to take the derivative with respect to x, so I see that x squared plus 25 raised to power 3 over 2. So we notice that here we have x, but here we have something else, not only x. So we have a whole function. So in this case, we cannot simply apply our power formula. We need to do some more work. So if we let the inside expression as u, so u is equal to x squared plus 25. So our function becomes y is equal to u raised to power 3 over 2. So now this looks something like x raised to power 3 over 2. So we can say that y is a function of u and u is a function of x. So this is an example of a composite function. So whenever we have composite function, we apply the chain rule for derivatives. So y is equal to u raised to power 3 over 2 and the u is x squared plus 25. So what I can do, so if I want to take the derivative, so in this case I can find, since this is a function of u, so I can find the derivative with respect to u. So in that case, we are finding the derivative of u raised to power 3 over 2 with respect to u. And we notice that here u and u, so these variables are same. So it means we can simply use our power rule. So dy over du would be, bring the power down, decrease the power by 1. So in the other one, again, if we notice, we have, so u is a function of x, so you can find du over dx from here. So taking the derivative with respect to x on both sides, and you can write this as the derivative of x squared plus derivative of 25. So we get 2x. So if we analyze this situation now, so what we have? So we already find dy over du, and we also have du over dx. But what we want, so what we want is dy over dx. So implicitly we can see that if we multiply these two together, so du and du, the differential of u gonna get cancelled and we're gonna get our dy over dx. Thus, the chain rule is, so dy over dx can be obtained, so multiplying dy over du times du over dx. So you can see that here this cancels, so it gives our dy over dx. So that is our chain rule. Therefore, we get, for this one, we get dy over dx would be dy over du. So in this case, that is 3 over 2 u raised to power half times du over dx, which is 2x. So now we can plug in the value of u. So we get dy over dx is equal to 3 over 2. So u was x squared plus 25 raised to power half times 2x, and we notice that 2 and 2 gets cancelled. So in the end, we are left with 3x x squared plus 25 whole thing raised to power half. So that is our derivative of this given function. So this was a long way to do a question using the chain rule. I did this all these steps because I wanted to show you that where does the chain rule come from. But now I will show you how I would think about a problem when I'm applying the chain rule. So for example, if we start with the same expression, so we are given y is equal to x squared plus 25 raised to power 3 over 2. So this function is a composite function. It is made of an outside function and an inside function. So inside function is x squared plus 25, and outside function is that inside raised to some power. So outside function is our power function. When we take the derivative and apply the chain rule, so I will take the derivative of outside function. Outside function is the power function. So bring the power down and reduce the power by 1 times derivative of inside. So derivative of inside, which is derivative of x squared plus 25. So here we had this expression. Okay. So 3 over 2 x squared plus 25 raised to power half, and derivative of x squared is 2x plus 0. So 2 and 2 cancels, we get 3x x squared plus 25 raised to power half. So for the chain rule, other way we apply this is we take the derivative of outside times the derivative of inside. D outside times D inside. Let's do this example using our chain rule. So again, we notice here that we have an outside function and we have an inside function. So here our outside function is the power function and inside is a polynomial 6x cubed minus 10x plus 5, and outside we have power of some expression. So when we take the derivative, so just be systematic. So first we're going to take the derivative of outside. So something raised to power 15, it means 15 comes down and that's something, and the power is reduced by 1. And then derivative of inside. So derivative of inside means derivative of 6x cubed minus 10x plus 5. So that would be 18x squared minus 10, and plus 5 is just 0. So this inside was, I'm just going to fill in the blanks. So derivative of outside, so this is our d outside times derivative of inside. So that is our chain rule. Or the other way is you can plug in u equals to inside function, and then y becomes u raised to power 15. So from first one we get du over dx, which is 18x squared minus 10, and dy over du, because this is a function in terms of u, so we get, by using the power rule, 15 u raised to power 14, and I just plugged in the value of u, so I put everything back in terms of x here. And using the chain rule, we plug in the values in this formula. So dy over du times du over dx. So simply put the values and you get your required derivatives. So personally, I believe that this method is easier when I use d outside times d inside, so that it's like quicker method. The other one is like you just write all the baby steps. So you can choose what works best for you and just use the same method. Thus, in nutshell, another way of looking at the chain rule is, so if you have inside, so this is inside and raised to power n is outside. So what we do, so take the derivative of outside times derivative of inside. So d outside times d inside, that is our chain rule. So I hope you enjoyed this video. Please do watch the next video for some more examples which are a little bit more complicated, and keep learning.